I want to show that now we can distinguish source and destination from each other.
And how do you distinguish the source and the destination? There's two ducks.
Yes, every marker has its own ID. So from 0 to 3, from 4 to 7.
What other demos do you have?
Oh, it's kind of, I don't know if it's going to get there or not.
Don't be so pessimistic.
Yeah,
It
so
might work.
now you see what it sees, and it started to work. So here it shows that it's going forward. So now you can see it detects the markers, and it will say here where
did it say?
like the last line where it's going to go. So yeah, it says I'm going left now, and
Good.
go is going
So your
left.
code is working now.
Yes.
Congratulations.
It's kind of the current graph, and for each node it outputs the last right.
Well, they corrected. That's impressive.
Sometimes it works.
No, it worked.
It outputs here all the progress, or how much information about the map it knows and where it's going to go.
We had a problem with OpenCV. We narrowed it down that our main issue with receiving images was running OpenCV on iOS. And right now we're working on and we're getting close to transmitting the images from the drone to that server instead of processing everything locally. So this has kind of set us back in schedule. The main point is that our application started hanging up after a while.
So it has to walk around, find the airport.
Yes.
Great. I'm happy. Let's go to the next one.
My promise for today was to tune some parameters on Ducky board to allow it to move. The airport will be marked with this sign. Now it's random choice, so once it will reach the stop sign.
And it's recalibrating.
Yep. And it's try to avoid them. The only unfixed problem is the detection of red lines. I think I'll think about it tomorrow.
Yeah, congratulations. Good demo.
So, approximately, the duck is ready. I'm going to start the picking up command and we'll see if the car is in the correct position.
Well, we can see the intention. Actually, can you put the duck there? Then we assume it picked it up.
Yep, it's definitely picked it up.
Yes.
And I think it will be somewhere around here where it releases it. Maybe we'll even, like the release mechanism is really precise actually. So we'll see, maybe we'll...
Yeah.
Close, close.
It released it. These are good demos. How's the communication between your commands and the board?
There is a Wi-Fi on this Arduino.
You can actually see the antenna here.
Yeah.
Today we was figuring out how to detect markers and to extract the important information from them. The yellow lines is the problem, the red lines is the problem. I will detect several red lines. I'm not sure that I will be able to join intersections. Now we don't know why. Okay, this is the extracted information of the whole city.
Okay, good. That's a good shortcut. Is he still excited? Or now you're going to see a drone.
If the drone goes crazy, you can go out the door.
Our plan here for the hooking technique was to put the duck with some magnets on the bottom of our drone, and as soon as the camera turns, it uses a hook to throw it off.
That was a real drop-off.
Yeah, here it can connect.
Good.
So we'll have this thing attached this way here, and the duck was placed here, and we would just rotate like this when we want to drop it off. But the thing is that you can't rotate the camera more. Rotate the camera this way, so we would just drop it off like this, but you also can't turn it this way more than 10 degrees.
With our demo, we should be able to autonomously lift up the drone, fly to the defined coordinates that you will say us, and land there safely.
That would be impressive. Are you confident?
You can rotate it any way you want.
Oh, you mean I can even put it here for the camera? Look.
Yeah. Yes.
Yeah.
Yeah, no problem.
That one, yes.
25-1.
10, 9, 8, 7,
to connect the iPad to the controller.
6, 5, 4, 3, 2,
1.
Lift off. What's it in a loop? But these are all good law examples.
3, 2, 1.
Bravo!
That's cool, yeah.
The first thing that the drone is doing is basically trying to rotate so its axes are aligning to the
We saw
coordinate
that on the first
systems.
demo.
Exactly. But sometimes our commands are sent out of the iPad, so we get logs information from the iPad that it's sent out to the controller. It works like 8 out of 10 times.
Look, Mom, no hands.
It should investigate sending out the signal.
That was good. Level 2 autonomy.
It knows that it has to land. What we achieved is today that Paul implemented vector-based control, so we can set a direction in which the drone is going to fly, and also set that it should rotate with a given rotation speed. So we definitely need to, first of all, fix the controls, and then the next step would be to actually program the approaching of the ducky car.
Then, in this case, you have a round-trip request-response protocol.
The thing is, what we could try is maybe, so what would be a good idea maybe is to just stop sending commands at that point and restarting the whole process thing.
Excellent.
Well, let's see what
Oh,
what
it
just
was an
happened.
obstacle.
Yes, it will recognize it as an obstacle.
Initial startup. How long did it take to start up? Okay, now it's thinking
Now it's thinking.
and it's twisted.
Every white one is an obstacle.
So what did it find?
Find the way straight ahead.
So your road will be consisting of road markers. For sure, this is their proof. Okay, so I'd say it was a great, successful demo. 1.5 per demo.
We are in the middle of the school.
Controlling the drone is like a try and error process. Basically, it took us a long time, took myself a long time to basically figure out how to control everything and what the best way to do is. And in the end, I think today was mostly about just combining our approaches with Thales navigation code of mind controlling. So basically to figure out how it perfectly works together and to have a smooth or mostly smooth flight path in the end. But we're working on that tomorrow too.
Okay, thank you. And let's see, I think the demo day is finished. The evening starts.